Hello, today we're going to do the P3 application of physics, and it's the one from June 2014, and we're going to walk you through it, hopefully getting full marks. So as you turn your page, you find the formula page, and there's lots of different formulas that you can use, and this means we're going to reference this during our exam, showing you which equation you should use to get the full marks, according to the paper, of course. Question 1. The lens shows diagram has a focal length of 12 centimeters. Complete the sentence by putting a cross in the box next to your answer. This lens can produce, and then it gives you different things it could be. Of course, this is a convex lens, so it focuses on image in one single point. It does not diverge the light, and it asks you which one is it. Now, depending on where the focal point is, it depends on what you can have. In the P3 booklet, you would see that if it was before the focal length, you get an image, or after the focal length. So when you're using a convex lens, you have both real and virtual images. Here. Question 2. The power of the lens is, and also gives you some questions, but you'd have to reference to the first page. So let me show you that. Taking it from the other page about the formula, you would use this formula. Power of the lens equals 1 over the focal length. And it gives you here, the focal length is 12, so 1 over 12. Of course, this is in centimeters. And it's not in centimeters, it's actually in meters. So it would be 1 over 0.12, because you have to do the units. And that would give you 8.3, because you divide by 100. For the next question, the diagram shows a converging lens with its focal length marked. Over the diagram, draw a converging lens of a greater power and mark its focal length. So it would have to be, if I draw it on, just above it, around it I mean, like this. So it's really inaccurate. And this will get you the 2 marks. So it's just fatter, so you can have a greater power. And now for the second question, I need to write this down. An object is placed 8.5 meters in front of the converging lens with a focal length of 12 centimeters. Calculate the image distance. So you look at the first page, and you'd see the relationship between focal length, object, and image distance is given to you on the formula page. So it's really nice. 1 over f, that's what the focal point, the focal length, and then you have 1 over u and 1 over v. The way I do it, and I find it's the easiest way, is you say we can see the focal length is 12, so 1 over 12. Then you would know it's 1 over 8.5. It doesn't really matter which way you put it, because you're also going to get the same mark. V. And then let me make this smaller so you can see. Okay, so the next part of the question, not even the next part, the same thing. 1 over 12, take away 1 over 8.5, gives you 1 over v. So if you put that in your calculator, you would get, this will give you minus 7 over 204. And then you only have to press the button on your calculator that looks like this, x, which gives you the inverse reciprocal, like this. And then this gives you, if you press it, it gives you minus 29. And that's the answer, which could give you 4 marks. Question 2, it's about the critical angle. The diagram shows a ray of light incident on the boundary between air and glass. The critical angle of glass and air is 42 degrees. Which of the diagrams show the ray of light that meets the boundary between glass and air? And it gives you 4 different possibilities. The answer is B. This cannot be correct because it's total internal reflection, because it's from glass to glass. This cannot. But this could, but this is why lots of students in the exam report got this incorrect, saying that they put this because it's bending away from the normal. But it's actually, this is the correct answer, B is. The diagram shows endoscope to see light inside a person's stomach. The diagram shows an endoscope to see inside a person's stomach. The light is shone into the optical fibers using endoscope A, and it comes out at B. It gives you A, and here's B. The cross-section area of the optical fiber, and it gives you some numbers here, and then it gives you the intensity as well. So you look at the front of your paper, and you see it's this equation: intensity equals power over area. And we need to find out the power. We need to find the power. So you do intensity times area, and it gives you power. So if you put this into the calculator, so the intensity is 3.2 times 10 to the 7, and then that is times by 6.3 times 10 to the 6. And if I put this into my calculator right now, so this is, if you can't see, it's minus. So if you put that into calculator, it gives you 201.6. So you put 200, you get 3 marks. If you put 201.6, you also get the 3 marks. In the optical fiber, all the light rays entered are totally internally reflected. This is called, you can say it's shorter in the way that you want, but this means none of the light energy refracts and leaves the glass, so the power remains the same. So if you have some light coming in from here, and it's been totally internally reflected, see if I'll draw a small one like this. Sorry, it's not supposed to go up. All the light is being reflected inside. So if it's being reflected all the way inside your stomach, or wherever that's going, it's to the stomach, it means all the energy light rays are still going to be there. So you're going to have the same power of light, and that's what you say to get 2 marks. The optical fiber cable in the endoscope has a refractive index of, here saying 1.7. The critical angle for the material can be calculated using the equation, and it gives you the equation right here, so you don't even have to go back to the first page. And here it gives you a graph as well, and it gives you for the angle, and it gives you a graph. Use the equation and the graph to calculate the critical angle for the optical fiber. When I first looked at this question, I was a bit confused because I didn't know how to calculate this. But actually, you don't need the graph to calculate this. You can just put it inside the equation. So sine C equals 1 over, and it gives you 1.7, so 1.70. You put this into your calculator, and when you get it, you need to leave C on its own. So what you do with this, you would have to know that you need to do the inverse. So that's sine inverse, that's -1. And you put this into your calculator with 1 over 170, and this will give you 36. So for this question, it is really misleading in my opinion, and you need to know this, so practice your maths doing lots of these equations. But also you can get the marks, I think, from 34 to 38 if you use the graph, so they're a bit lenient in the mark scheme. Question 3 is about X-rays. Lots of things to talk about. The photograph shows the security check in and out of an airport, and it gives you a photograph of what you would normally see in an airport, which is not very interesting. There is a metal detector, there's an X-ray scanner. An X-ray machine is used to scan luggage for dangerous items. A metal detector is used to check for people for dangerous items. Suggest why people are not scanned with X-rays in an airport but have X-ray in a hospital. To get the 2 marks for this question, you would need to say, because X-rays are ionizing, and if used to scan someone, it could damage their cells, possibly causing cancer. This is the reason we don't use them in an airport. But in a hospital, you would need to use it because it's for diagnosis, and this is why we use it in the hospital. You need to limit the amount of X-rays, so we don't really need them in an airport. That's why we don't use them. The security people work near the X-ray machine. Explain how they're protected from X-rays. To get the 2 marks, the only thing you have to say is that they're protected by lead casing, which absorbs the X-ray. And this will give you, just say lead casing and then absorbs the X-rays. X-rays are produced when fast moving electron collides with a metal anode in the vacuum tube. electrons from the cathode produced by thermodynamic emission. Explain what this means. You have to say is when it's heating the cathode, and this means to a really high temperature, and then this means the electrons boil off and they move. The answer for this is C. For this question, it's a maths question, so you need to really practice before your exam, just in case it comes up. And in this exam, it does, so let's get started. For the first question, it just talks about, in order to produce an X-ray which penetrates the luggage, each electron must have at least energy of this much, and the charge of an electron is this. Calculate the accelerating potential difference which will produce electrons of this energy. You look in the beginning of your exam book, and it starts with this equation, which is half mv squared, equals E times V. So we know this is velocity, and this must be voltage then. So they want us to calculate potential difference. Potential difference is the voltage. So we need to rearrange to get V. And only thing you have to do is half mv squared divided by electrons equals voltage. And if we do that, now we have only two numbers here. We have 1.4 and we have 1.6. So what you need to do is that we must understand what these mean. One of them actually gives you the half mv squared, and this is 1.4 times 10 to the negative 14 divided by the electrons, which is 1.6 times 10 to the negative 19. Insert that into your calculator and you will get 8.8 times 10 to the 4. Put that in there. You can put it in the whole volts instead if you want to expand this, which will be, I believe, 88 and then 3 zeros. Do that and you get 3 marks. Question 4 is about kinetic theory of gas. Kinetic theory describes the behavior of gas particles. Complete the sentence by putting a cross next to the box next to your answer. And it says minus 273, the gas particles are. So if we have revised, you would know that minus 273 is absolute zero. So when something's absolutely zero, is it going to be moving rapidly, moving slowly, stationary, or vibrating? Now, it can't be moving rapidly or slowly because it's absolute zero. So, and when something's not moving at all, it means it's stationary. So the answer would be C. The temperature of gas changes from 300 to 150 K. State how the average kinetic energy of the gas particles changes. Really simple, it's only 1 mark. You'll have to say kinetic energy decreases by half, because 300 divided by 2 is 150. This question is about a balloon, and they're talking about pressure and all the other types of gas particles. So photograph shows a weather balloon filled with helium. It rises rapidly, and it shows you how much it rises and things like that. Explain how helium gas exerts pressure on the balloon. This is really simple. I don't think this will get you 3 marks. Make sure you say something extra to it. But I just thought of like particles in the balloon collide with each other. This means it has internal pressure, which causes the balloon to go up. Oh, balloon spot incorrect here, sorry. It causes a force on the side of the balloon and it makes it go higher. And the second part of the question, it talks about kelvins and Celsius, and you just need to make sure you know what the difference is. And if you know that, you'll get this really easy 1 mark. So minus 46 plus 273, which is absolute zero, which gives you the kelvins. If it was the other way around, you'll need to know how to do it as well. It's very easy, very simple, make sure you learn it. Calculate the volume of the weather balloon when it's a height of 30,000. You look at the front of the exam paper, and you realize which one you need. The one that you need is the same numbers you're using from the beginning. So you need the pressure one, and you need the volume one over the temperature, that's why, because you need to get the volume number 2. Then you plug the numbers in. That's 101 times 9.1 over 273. This equals to 1.21 times the volume 2, because we need to find that. We divide it by 227. When we have this, then you only need to do is rearrange the equation so you can find V. I find that if you plug the numbers in, then rearrange, it's much easier to do the calculation and put it inside your calculator to get the answer. So that would be the same, 101 times 9.1 times 227. This is being divided, so you need to times it, and then you times at the top because it's cross multiplication. Then you all divide this by 273 as we had before, and we times it by 1.12, which it was being times. When you flip it, it'll be division. So plug this into your calculator, and you will get 882. The next part of the question, it asks us what will happen if it goes above 30,000. Simply for 1 mark, you need to say it bursts or it pops, and that'll get you the mark. For question 5, antiparticles. Positrons are antiparticles of electrons. The photograph shows a PET scanner, which uses positrons to locate a site of a brain tumor. Positrons are emitted from a radioactive isotope fluorine-18. Fluorine-18 is attached to glucose. The glucose is injected into the patient's bloodstream and collects the site of the tumor. And you can say advantage and a disadvantage. So the advantage for this is that it minimizes the patient's exposure to radioactivity. And the second thing you could say, it has to be produced in hospital because isotopes won't be reactive anymore if you have to transport them, which means the cyclotron has to be on site in the hospital. Explain when a positron meets an electron, they annihilate with each other. Explain how this enables the site of the tumor to be located. It's 4 marks, 4 points, get the 4 marks. This answer is actually taken from the examiner's report, and you have to say 4 things to get 4 marks. Say about gamma rays, talk about the 2 gamma rays being emitted, their opposite directions. It's the idea of triangulation, of getting 3 points to locate exact pinpoint. This is what they've said, this got full marks. Aim for something like this. The radioactive site of the tumor releases a positron. This meets an electron and they annihilate with each other. This releases 2 gamma rays that travel in opposite directions with the same amount of energy. These are detected by gamma ray detector. The same time it draws a connecting to the points. This happens many times. The items are created from the gamma rays across and where they meet the tumor. So it's about triangulation. Say that is better than saying lots of different points, because of course there's lots of different points, because electrons are always in your body. You're getting a positron, they annihilate, and then you get gamma rays, which then are detected by the PET scanner. So make sure you mention this, you'll get 4 marks. For the first 6 marker, here we actually took this from the examiner's report, and this candidate got full 6 marks, which is what we're aiming for. And the question is about quarks and positrons and electrons. So this is what it says. Positrons, beta minus decay, are emitted from the nuclei of some atoms. Electrons from beta minus electrons, so I think that says beta plus, are emitted from the nuclei of some other atoms. The table shows some information about quarks. There's up quark, down quark, and then gives you the charge. So this person has written here about what proton means and what neutron means. So here the proton is up quark, down quark, and then the neutron is down quark, up quark. When beta plus particles are emitted from the nuclei, a proton is being turned into a neutron. There is too many protons that are in an atom. In terms of quarks, this means that a quark of 2/3 is turned into down quark of -1/3, -1/3, in order for the neutron to be formed. When beta minus decay, particles are emitted from nuclei, and neutrons be turned into a proton, and there's too many neutrons in that atom. In terms of quarks, this means a down quark of 1/3 is being turned into, and then that will tell you into an up quark, which is +2/3. Saying all of these points will give you the talking about up quarks, see what happens when beta plus decay and what happens in beta minus decay. Saying about what it is, mention the charges, and you'll definitely get 6 marks. For question 6, it's about cyclotrons and collisions. A cyclotron accelerates a charged particle. Describe the shape of the path the particle takes in a cyclotron. So as we know in the cyclotron, it goes round and round and round. So this could be even called a cyclic motion or a spiral. Explain how radioisotopes can be produced by cyclotrons. For this, you'd only need to say a couple of things to get 3 marks. For the cyclotron to work, it needs to have normally you just put a proton. So we need a fast-moving proton. And this gets absorbed. By saying absorbed, you get 1 mark. Absorbed by nuclei. And this produces unstable nuclei. I'll type this up because my handwriting is awful. But just say fast-moving proton is absorbed by a nuclei, which produces an unstable nucleus. In elastic collision, there's a conservation of, and then you have to pick one. You have 25% chance of getting it right. But always in inelastic and elastic, there's a conservation of momentum. And inelastic means that the energy gets transferred into heat energy, sound energy. And so it can't be kinetic energy and it can't be momentum. But if it was elastic, it would be C. State why momentum has the unit of kilograms per meter second. Now think about what is momentum and what is the equation for momentum? You have to recall this to get a mark. So think about it. Momentum equals mass times velocity. The mass is kilograms, and velocity is measured in meters per second. So when you have kilograms plus meter second equals kilograms per meter second, and you get 1 mark. This is the last question in the exam. Make sure you have enough time to do it because you want to get 6 marks. If you don't, 4 marks is good enough, but make sure you get 6 marks. Well, okay, there's collision 1 and there's collision 2. Different types of collisions are shown in the diagram. Analyze both the collisions in terms of momentum and kinetic energy. Diagram 1, and you need to explain 3 points in this, 3 points in this, you get 6 marks. Make sure your grammar is correct, make sure there's no bullet points. If there's some bullet points, you'll lose some marks because it's not correct, because they want it in full answered sentences. For diagram 1, the moving in opposite directions before the collision. It's an inelastic collision. Make sure you know what all these terms means because you might have to explain them. Stationary after collision, momentum 0 after collision. Therefore, total momentum must have been 0 before collision if they're moving at the same speed, assuming they have equal mass. The kinetic energy is 0 after collision because the kinetic energy is converted into heat, sound, and elastic potential energy. And the second one, diagram 2, shows 2 different types, moving one side to the other side. And you should also know this diagram anyway from before. It's an elastic collision, and momentum is conserved. Of course, momentum is conserved in both. Momentum transferred from the first to the last sphere. Kinetic energy is conserved. Nearly everything is. But also remember that the last sphere reaches its maximum height first. Sphere. 3 spheres also have 0 momentum because this small amount of energy is transferred into sound and heat. Always just a little bit, not all of it, like in collision 1. Say that and you'll definitely get 6 marks. Make sure you check out our channel, and it's Ask Jake Chemistry, our science teacher, and we have done a B3 and a C3, and you can check it out on the playlists. And there's another link to Study Smart, which has lots of different video tutorials to help you for exams in the next couple of weeks. So, and there's one about moles and titrations, which is the correct level for C3. And I wish you lots of luck in your exam.